There are 8 books on a reading list for English 1. Students must select 4 books to read from this list, and how many ways can the 4 books be selected? So this is either a permutation or a combination, and the difference between those two is that for a permutation, the order matters, and for a combination, the order doesn't matter. And so when we say order matters, we're talking about like we're picking 3 people out of a group of 5 to be president, vice president, and secretary, or 10 people are running a race. What are the different ways that first, second, and third can happen? That's where order matters. So in this case, where we're talking about 8 books and we're trying to select 4, that's simply a combination. We would do 8 choose 4, which in your calculator you go to math, you go over to PRB. Before you do that though, type in the 8 and then do math PRB, then put 4, and it'll tell you that that is 70. Expand the binomial. So this one's kind of complicated-ish. We're going to use our calculator to help us. You can use Pascal's triangle, or we can do the NCR button. So we would do 5 choose in our calculator, but then you're going to put in a squiggly bracket, which you get to by pressing second parentheses. And inside of our bracket we're going to start at 0 and list all the numbers until we get to the exponent that we have. So we're doing 5, because that's what this is, choose all the numbers between 0 and 5. And what that should give us on our calculator is these numbers. 1, 5, 10, 10, 5, 1. Okay, and what happens is there's this pattern to binomial expansions where we use a's and b's, and so our coefficient for the first one is 1. It's a to the 5th b to the 0 power. And notice those exponents add up to 5, which is the power that we're raising this to. And then we'd have 5 a to the 4th, b to the 1st. So as the first exponent decreases, the second one is going to increase. And it just keeps going like that. And so then on this, we don't have an a and a b here. We have a 4x and a negative 2. So for this particular problem, our a is 4x, our b is negative 2. We need to plug those in. So this is really 1 times 4x to the 5th times negative 2 to the 0, and then 5 times 4x to the 4th times negative 2 to the 1st power, and so on. I didn't mean to put that negative there. And there should be a 3 there. And I ran out of room, so I'll put the last one down here. Alright, so we need to work out some stuff. Like on this first one, we need to do 4 to the 5th power. Negative 2 to the 0 power will go away, and when we multiply by 1, we'll just get whatever 4 to the 5th power was. If we put that in our calculator, we get 1024. That's x to the 5th. And then I stuck a plus sign there, but it's not really going to be a plus sign, because what we want to do is on this one is 4 to the 4th power. We're going to multiply that by negative 2 to the 1st power and multiply that by 5, and that gives us negative 2560 x to the 4th. And then we're going to do 4 to the 3rd power negative times negative 2 to the second power times 10, which also gives us 2,560. And then we're going to do 4 squared times negative 2 cubed times 10, which gives us minus 1280x squared. And then 4 to the first power times negative 2 to the fourth power times 5, which is 320x. And then this goes away, so we just need to do negative 2 to the fifth power times 1, which is negative 32. This right here is our binomial expansion. On 37, it asks us just for a specific term. Since these are x and y and they don't have any numbers in front of them or anything, then that makes this pretty straightforward. I think the easiest thing to do, to be perfectly honest, is to do 11, choose, and then put in all of the numbers into your calculator. And so you'd stop at 11. And then think about what term would have x to the 6th, y to the 5th, and basically count. So we would start off with an x to the 11th term, and then we would have x to the 10th, and we'd keep counting down until we get to the x to the 6th. So if you do this, then you're looking for the 1, 2, 3, 4, 5, 6th coefficient, and if you do that correctly, you should get 462. Alright, number 41, find the derivative of the function at the specified point. When we want to find the derivative at a specified point and we're using the limit definitions, then the way to do it that's typically easier, the easier formula to use is this one. The limit as x approaches a of f of x minus f of a over x minus a. So let's plug things in. So we're trying to find f prime of 1, which means this is the limit as x approaches 1, because a is 1. We're going to put in f of x, which is our function, x cubed plus 5x, minus f of a. So that's what we get when we plug in that 1 into our function, all over x minus 1. So we need to figure out what 1 cubed plus 5 times 1 is. That should be 6. And now at this point it's like, where do we go from here? We've got an x cubed. We really haven't done anything with x cubes. I'd like to recommend that we use synthetic division. We want to divide x minus 1, which means we put in a 1, into x cubed plus 0x squared plus 5x minus 6. If we do this synthetic division, then what we end up with will actually be what we would get if we had factored the top and then crossed out the x minus 1s. So 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, 5 plus 1 is 6, 1 times 6 is 6. So remember that we start off writing 1 degree less than what we had whenever we were dividing. So this is x squared plus x plus 6. So when we do x cubed plus 5x minus 6 divided by x minus 1, that's kind of like if we do, like 24 divided by 6 is 4. We don't make it 4 over 6 because that's not the way division works. And so if we're dividing x minus 1 into x cubed plus 5x minus 6, that means that x cubed plus 5x minus 6 is no longer there. So now we have the limit as x approaches 1 of x squared plus x plus 6. We don't have x minus 1 on the bottom anymore, so we can plug in our limit. 1 squared plus 1 plus 6 gives us 8. This one also says find the derivative at a specified point, so again we can use that same formula that we just did a second ago. The other formula that we won't necessarily have to do on this one, but we could use, again, is the limit as h approaches 0 of f of x plus h minus f of x over h. And one thing you can do if you are trying to find it at a specific point is if we want, and let's go ahead and do it this way, if we want to find f prime of negative 4, then we want to do the limit as h approaches 0 of f of negative 4 plus h minus f of negative 4 over h, because what are we doing? We're going to put in a negative 4 where x is. So that's one way that you can use that other definition. Let's try this. It's one way we can use that definition instead. So we have the limit as h approaches 0 of f of negative 4 plus h. So that's negative 9 over negative 4 plus h minus f of negative 4. So that's negative 9 over negative 4. And it's all over h. This is actually really similar to what you get if you do it the other way, just so you know. Let's see here. These are going to cancel each other out so that it's still going to, but it's still going to have this minus sign here. We can get a common denominator on the top and bottom here by multiplying this by 4 and this by negative 4 plus h. So the limit as h approaches 0, that's going to be negative 36 minus 9 times negative 4 plus h over 4 times negative 4 plus h all over h. Okay, so what happens here? Let's distribute on this part and this part. So negative 36 plus 36 minus 9h over negative 16 plus 4h. This is all over h, which is the same thing as h over 1. Now, those cancel. We have negative 9h over negative 16 plus 4h. What we can do is we can take this and flip it up so that we multiply by the reciprocal, and that cancels out those h's. So now we have the limit as h approaches 0 of negative 9 over negative 16 plus 4h. But we want to evaluate the limit here, so we want to put a 0 right here where h is, which means that this is really 9 over 16. And that is our answer. The other way works pretty similarly, where using the other definition, works pretty similarly. It might be a little bit easier, might not, but you should still get 9 over 16 either way. Alright, 43, find the equation of the tangent line to the curve when x has a given value. Now keep in mind that an equation of a tangent line is going to be y equals mx plus b, which means that we could probably use point-slope form to get it into y equals mx plus b. And so that means that we need two things. We need the slope and we need a point. So let's start off by finding a point. We know that x is going to be 4, so we need to find f of 4. So that's 4 squared plus 5 times 4, which is 36. Okay, so now we have this point 4 comma 36. Now we need to find the slope. So to do that, we need to find f prime of 4. So I personally like the definition where we find it at a point. So that's what I'm going to use here. So that gives us f of x on top minus f of a, which in this case a is 4. And we already figured out that that was 36. Okay, because f of a is what do I get if I plug 4 into the original function? Over x minus 4. Now on top here we can factor this factors into x minus 4, x plus 9, because we're saying what multiplies to get negative 36, and add or subtract to get 5. X minus 4 is cancel, leaving us with the limit as x approaches 4 of x plus 9. We plug in that, 4 plus 9 gives us 13, and that's our slope. So if that's our slope, we're ready to plug into point slope form. Y minus y1, which is 36, equals 13 times x minus x1, which is 4. Let's distribute. 13 times negative 4 is negative 52, and then add 36 to both sides. And that gives us 13x minus 16. Compute the average of the RAM and LORAM approximations to estimate the area between the graph of the function and the x-axis over the given interval using the indicated number of subintervals. So we're graphing from 0 to 4 subintervals. That means each of our rectangles needs to be 1 wide. So here's my graph. And what I would do is I would plug in this right here to your calculator into y equals, and then go to the table of values so that you can graph this. At 0, we're at 14. At 1, we're at 18. At 2, we're at 20. At 3, we're at 20 again. At 4, we're back down to 18. And so here is that curve. And so we need to do the LRAM, which stands for Left Rectangular Approximation Method. The way you do that is we want 4 rectangles here. We want this right here to be a rectangle. And so the LRAM, I don't know why I started with that one instead of the R, but whatever. The left one, you go up to your graph on the left side, and then when you hit the graph, you go over and you make your rectangle. Then at 1, we have a rectangle here. So we go up at 1, we go over, and we go down. At this rectangle, we go up to our graph, come over, and come down. This interval, we go up to our graph, come over, and we go down. So what are the heights of these rectangles? This one is 14. This one is 18. This one is 20. This one is also 20. Each of them is 1 wide. So we add them together, 14, 18, 20, and 20. We get 72 times 1 is 72. Now I do the same thing over again for the RRAM. Same exact picture. Until we start drawing the rectangles, of course. Alright, so now for the RRAM, the right side of the rectangle, so this first rectangle, the right side needs to come up and touch the curve and then go over. So there's my first rectangle. Here's my second rectangle, third rectangle, fourth rectangle. So this one has a height of 18. This one is 20. This one is 20. This one is 18. So 1 times the heights added together, which is 76, the RRAM is 76. It tells us to compute the average. So 72 plus 76 over 2, which is 74. Find the definite integral by computing an area. So we need to draw a picture. The important part on our x-axis comes from the 2 and the 7. And then we need to graph this 0.5x, y equals 0.5x. And so we're looking at the area between 2 and 7 underneath that line, 0.5x. So this is a trapezoid. The area of a trapezoid formula is 1/2 times the height times the bases added together. So our height is actually how far it is right here from base to base. Our bases we get from saying if I plug in 2 to the function 0.5x, then I get 1. So the height of this is 1. If I plug in 7, I get 3.5. So this is 3.5. So A equals 1/2 times the height times the bases added together. That gives us 11.25, or as a fraction, that would be 45 over 4. Alright, we need to start off on this finding the area again by drawing a picture. Now this time we have something interesting going on with our function. 5x minus 4 is a line that starts off at -4 and then actually has kind of a steep slope. And so we want the area from 1 to 6. So if I plug in a 1 here, I get 1. So we're saying when my function is 1, I'm at 1. If I plug in 6, we get 26. So let's pretend this over here is 6. That makes this up here 26. So here's what we're trying to find the area of this trapezoid. So area equals 1/2 of the height, which is 6 minus 1, which is 5, times the bases. The first one is 1, the second one is 26. So 1/2 times 5 times 1 plus 26 is 67.5. Or as a fraction, that would be 135 over 2.